What up? Welcome to the lab. Last time we implemented a very simple list implementation, so basically our own version of a std vector, but I'm calling it list. And yeah, it's very simple. It just supports adding and iterating basically. What else do you need for a list? So yeah, and now I think we are ready to start working on our actual library. But first of all, I noticed that I forgot to commit the changes, the iterator code. So let's just begin doing it. We'll begin doing so. So let's just say add list and begin and list and methods. I think we are already. Oh no, maybe it's a little bit cryptic. So I think, yeah, okay. Let's say sort rating over elements using for each loop. This is done by adding a begin and end method and supporting all operators required for input data. Oh, just as a simple message, and let's use a more explanatory commit message. Okay, so now that we have a list, so now I can just try to implement our specification. So in the first video of the series, we analyzed and had a look how our API of our library could look like, and I'm just going to implement it now. This one doesn't compile, but I will gradually. So I will today. Well, I'm not sure. We will just look at how this class could look like. So the specification class just holds the user specification for now. Let's start with this. So, and then let's just go straight ahead. And so maybe one more video, data management for the library, and the next video we will work on the main function. I think this function will be the rest of the video series. Maybe we will cut it somehow so that I don't have one video that does it all. Yeah, let's see. So let's just use a class. So first of all, I would like the scanner generator library that the goal of this video series. I will define it as a new library. So let's just start by adding a new directory. How did we? So I thought of a name. I would like to call it sigil. So how is it? Is it sigil or sigil? Let's see. Sigil. Yeah, okay, it's English. No, I don't want to. Sigil, okay. Actually, pronounce it more or less correctly. So I'm calling it sigil, and I will just yoink the file, and we will just remove everything as think. And it is a library, and the library is called sigil, and it target link library, but it links to my core library. This core. That should be it. Now I just have to include it here. Sigil. Now let's also I think this should be fine. So, and also let's link to this test sigil. Why doesn't it sigil? Okay. What did I do wrong? No sources. Okay. So let's just add the first class called. So maybe let's just talk about why I chose the name sigil. So a little bit of trivia. Scanner generator. If you take the letters of the two names, you called SG, and then I just filled out some letters that is actually a pronounceable word, and sigil is also like a rune or something. So quite magical. So I like the name. So that's a little bit of trivia. So let's introduce a class which I'm going to call like this one. So I'm basically implementing this class. I'm starting with this class. Let's call it specification. Let's just introduce a namespace, sigil, a new namespace. And yeah, let's see if it links. So now I have specification.a and specification.cp. Okay, now it links. So let's include sigil specification. Yeah, so let's remove everything from our main, and let's use a instance of specification. Fine. So now I would like to basically just implement this. Very basic. Just copy and paste it. And how am I going to do this? So I will have a private. So let's include core list, and I will list. So how do I want to do this? So let's basically add a internal struct, which I'm going to call token spec, since it describes token. So then we have a string view, the name of the token. Then we will have a string view, which is a name. So basically this holds the parameters of those methods. So I also have to differentiate between the two types. So token spec kind. Let's just call it type and be a byte. So we have either a literal or a regex. Those are the two, not the types of the tokens, but those are the types of token specifications. Yeah, okay. So, and then this is I'm just going to call it pattern. Depending on the type field, which I'm going to add. Well, just use another type, which is basically the I just accidentally create an instance of this, and it will be invalid internally. So if I now have a list, I'll keep a list of token spec token tokens. It's tokens. Token modifications. So I'm keeping it a little bit short. This is meant to be internal. So what is your problem? Name pattern. What? Constructor does not initialize fields, but it should have. It has an empty constructor. What's your problem? So why does it cry? So it should be fine. Okay, fine. Okay, fine, clang tidy. I'm writing it like this. Ooh, what is your problem? Oh. Like this. That's unfortunate. But I'm sure I can do this. Oh. I have to swap this. Ah, ha ha ha. Just forgot to include this as well. Ah, yeah. So I just had to swap those lines. Okay, I'm learning every day a new thing. So then let's just, so I'm not going to I'm also, how do I want to do this? No, it's internal. Fine, it's fine. So let's not overcomplicate things. So I'm just going to add the tokens to the internal list. And how do I want to do this? I think I'm going to expose it, but let's do it later. So this is the token name. And in this case, this is the token. Okay, so in this case, it is the regex, of course, but in this case, it is the literal token. So the string, the exact token. Exact. Thing like this. Yeah. But I think I will implement those out of line. Yeah. So then let's just create a new token spec. So we are currently, can I just do something like token spec type? So we are currently adding a literal token. All the other fields, name and pattern, of course. Token name. Exact pattern. Oh, and I don't need to move it, but I like to move it. So, and then I'm just going to add it into the list. I think it is really trivial, very trivial. reveal. Oops. And now, of course, we are specifying a regex token. We just keep the data. So why doesn't it like to move? Yeah, it is totally copyable. Has no effect. Remove as remove. Yeah, okay, well, I'm not going to do. Okay. C++ com. So I mean cline clang format, clang tidy. I don't know. Clang tidy. Clang tidy is the linter, yeah. Okay, so now I have a working version of my simple specification class. Somehow the word looks wrong, the spelling looks wrong, but fine. So let's double check our draft. So we had well, I yoinked some code already. So now basically let's yoink code I wrote here, try if it compiles. So of course I chose to prefix my the scanner library with sigil and don't do the trick I'm doing in the core library. So basically I want to be able that the symbols to be defined as core colon class name, but I want to use it internally by just using the name. So I can achieve this by using the name directly in the global namespace that imports the symbol, but the symbol is still a core, in this case core colon list, but I can use it just as list. And I chose to not do this class, so I have to prefix it by the namespace name. So, but basically this looks as it could maybe compile. Let's run it. Okay, cool. Work. So I have 4 elements. Sure. This is okay. So the first one is a literal, type literal. The name is plus. Oh. I scroll here. I have to advance. And of course, so basically the first element in the list looks fine. So maybe let's do something. Yeah, okay, let's do something like this. Let's first of all let's print it. Let's how do I want to print the whole specification? Let's do multiple lines, I guess. No, I don't want to implement it. So maybe I should implement it for this. Not really sure. So I think this class should be fine. This is just a little class that holds my data. Of course, I later need a way to access the tokens. Or maybe I can do this now, but I only want const access token spec, not token type, of course, token spec. But let's move it here. That is publicly accessible. Yeah, sometimes my brain lags a little bit. I think you noticed. So let's just return the list. Method could be const extra, but I'm not going to start by annotating everything const extra just yet. So, okay, but now it would be quite handy that token spec is printable. So let's so now I would like to a logger. So template a specialization for class logger of type token specification. Token spec. Okay, sure. So and I accept it by const reference. So I had a similar problem earlier with string views, but let's see. I misremember or something like this. So I think I have to introduce a block method, a static block method. Yeah, okay. So I had expected that it actually works as well. So let's do the following. Let's just introduce a namespace sigil here too, as well. And then let's just drop this prefix here. That makes the code a little bit more compact, easy to read. Also here, so I see logger, but I think I don't need to prefix it. Do I? So let's move, just to be consistent, put it also into the core names. So let's specify it in the C++ file as well, I mean. So, and of course, here we get a single token spec. Token spec. And so I need to be able to log something. So core logging, not logger, but logging in this case. Because now I can just log open. Okay, now. Let's switch on the token type and handle all cases, and also let's handle the default case, false and unreachable. So this case valid. Let's just use fall through. In this case, I will just break. In this case, I will just print this. So we log. So we first log token back, followed by type, literal or regex, followed by a comma and a space. So I hate this code. So let's just say can I specialize? I think I can. So I'm just specializing this also for token spec type. So it will be even longer, the signature type signature. So let's just first create a logger for the type. Oh, create it. Why does it create it here? Don't like this. So I would like to create it here. Okay, so basically this. So this is unreachable. In this case, we're just going to print literal, and in this case, we're just going to regex. Okay, this is the type. So now it is, I think it's a little bit clearer to print. So because then I can just go token spec type, comma, space, token spec name, comma, space, pattern. Yeah. So, okay, now I can remove everything, reformat, and go. Okay. Okay, it can't link since process is already running. Thanks, Windows. Okay, so now let's just try to print out my tokens. Stack.tokens. Log token. What's wrong here? Please don't break. So what is your problem? Begin has type. Oh. Function is not marked const. Oh. Okay. Do I have to add a cBegin and cEnd as well, which are marked const? So please don't insert. This is how it works. So I have the talent to use a shortcut that I'm not really familiar with to change the layout of my keyboard. That's why it's misbehaving all the times. So do I really... So this argument to member function begin has type const. Blah, 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 blah. Function is not marked const. What? Let's read again. This begin. Ah, I see. Do I then have to... So this makes no sense, I suppose. Do I have to also add a const version of this? Do I have to add both? I don't know. Let's just add them. Just see if it builds. Okay, works. So what's his problem now? Ah yeah, that is the same problem I had with string view. So how did I solve it there? Do I have a logger specialization? I don't know how to fix this. I can't say I have a logger type const string view reference, but I can say I have a specialization for logger and take then a string view as a reference. So anyone knows how to fix it, so it might, then please leave a comment. So I think I did something wrong in my logger. So basically how it works, we implemented the logging mechanism in a previous video. So basically I use this as a method, the entry point to my logger. It just delegates to a logging helper with this templatized. And how this works is it just expands the argument list, just delegates for each call to log1. Log1, also call it log1. I like it a little bit better, I suppose. So log1 asks, requires a specialization for logger of t, and then just calls its log method with the value which was passed. And somehow this doesn't really really nicely work with const references. So, for example, if I have a logger for example, a signed 8-bit integer, I specialize the logger for this type and also implement a log method which accepts this type. But this is not the case for string view. It somehow doesn't work if I say const reference here and here. So I don't know. It seems for me like a hack. It should work and it must work, but I don't really know how to fix it. So yeah, so I'm repeating the hack here again. So I will just drop const reference from the logger template type, but this still accepts the template type. I don't know if it copies it. I have to double check it somehow. So no problem now. Okay, so now I have to also repeat it here, but so this now should compile. Builds. So let's run. Wow, works. Perfect. But yeah, of course, this. So maybe I want to force the user to tape this. So because I don't want to put a new line in, but I want to, basically the same as C regex. C++, of course. So I want to provide a C++ string containing /n. So yeah, so I have to escape this. So, but now it prints correctly, and I have missed closing parentheses. Let's edit. I think I have a bug in my logging implementation. So probably this method. Yeah, of course. I print a opening parenthesis. Maybe let's begin with a space. Also, I would like to have a space behind my pattern as well. So let's print it again. I think now it is easier to distinguish where the pattern starts and where it ends. Since also the pattern, for example, you could also just add it, I suppose. You could also add open parentheses, the closing parentheses. If I run it now, it just looks a little bit weird. If you have, well, opening parentheses, closing parentheses, yeah, maybe it's a little bit easier for the eye to distinguish the two, the symbols. So, but now this is a good entry point for our library, and so basically we can already express this. Also, we could express this. Also, we could encode errors, simple errors. We can't format string like this now. We have just string views, can't allocate strings to the heap, for example. So a little bit complicated to, but maybe we'll just add print methods for now. Yeah, well, I'm just planning ahead. So, but I'm quite happy we can already express this. So let's remove it from our to-do list, from our draft file. And yeah, we can also already evaluate the result of either values. So basically, we need only the code now, the main code, the code that does it all, the code to rule them all, basically. Quite pleased. So I guess we will have some fun the next time. We will use the specification. So this was just a boring video that prepared the data structure. for the next time. So next time we will introduce the method compile and we start working on it. Yeah, maybe we will split it to several chunks so that we can test it. Testing. I have another idea. So yeah, how do we test? So until now, I just packed something in a main file, but I actually want to keep some tests. Yeah. Well, let's just roll, see where we go, I suppose. So I did everything I wanted to achieve today, or let's say in this video, because I think I will going to record the next video as well, since I'm hyped. So now I'm going to implement this methods. Sorry, not this methods. Instead, working, actually building. Let's just call it scanner grammar. Not really sure how else to call it. So yeah. Okay, so that's all. Hope you enjoyed. Thanks for watching. Bye.